Ben, we're here at Mazak in Worcester. We're stood in front of the super impressive CV5-500 Simultaneous 5-axis machine. And you've got a lovely little demo on here, Ben. Perhaps you can tell us a little bit about it.
Yeah, so Mazak approached us to program this machine. It's the first time we've programmed a machine. Built in Worcester, here in the UK. So we've come down, written a post-processor for it, and we programmed a nice little leaf demo on there in aluminium. So we're showing off eye machining first of all on there, some barrel cutting, simultaneous 5-axis, and some automatic edge deburring as well.
So before we talk about the actual cam, the programming, what do you think of the machine?
Brilliant little machine, small footprint but quite a big envelope in there as well, so sturdy. We've done the eye machining in there, cope with it perfectly fine, nice and fast, yeah, really good machine.
So it's done everything the cam through at it?
It's done everything that come through at it, yeah. We do some high-speed machining. The barrel cutting on there is pretty quick as well. Obviously with a simultaneous 5-axis and it's reading that code pretty quickly, it's coped with it very well.
Sure. Now if we talk about the programming, eye machining, patented eye machining, just tell us a little bit more about that for the people who haven't come across it.
Yeah, so eye machining is sort of a two-pronged process. With the first side of the process is the morphing toolpath, so it's the shape of the toolpath, full depth of cut, and the second side of it is the technology wizard. So the wizard will actually look at the material properties, the machine properties, the tool itself, and it will set its own speeds, feeds, depth of cut, step over. And what we're doing is we're maintaining the chip thickness. So we're not maintaining a constant step over, we're looking at the chip thickness, maintain that chip thickness. We're increasing and decreasing this feed rates depending on the contact angles to do that.
And if we move on to the barrel milling, or circle segment milling, call it what you will, the 3D profiling, tell us more about that again. It's still fairly new here in the UK, tell us more.
Yeah, so a fairly new sort of technology in the UK. We've got into it quite well now, so we've got automatic strategies in SolidCAM as well for barrel cutting. We can use the whole of the circle segment tool as well, so we can not just using one spot on the tool, we can change the contact angle again, as a percentage up the tool. And again, it's sort of automatically picking the faces and letting it do its thing, really.
Sure, when we look at some of the barrel milling tool paths, they look pretty intricate, pretty tricky. How easy is it to program using SolidCAM? It's
pretty easy. Like I say, it's you're selecting the geometry that you want to machine, then set the parameters in the operation, and you're going to have the tool path. There will be some tweaking involved depending on leads in, leads out and things, but in terms of the barrel contact points, they're all set automatically by the software.
And just my final question, what's the cycle time, and how much quicker is it over potentially ball nosing if you weren't using this strategy?
Oh yeah, so the cycle time, overall the cycle time for the full component is about 43 minutes. We did actually ball nose the back of the leaf to show a comparison, so to do the front of the leaf and against the back of the leaf, you're looking at about 80% cycle time saving from a ball nose to the barrel cutter. The barrel cutter is doing about 2mm step down. With the ball nose, we're about 0.3 step over, I think we were.
So for 5-axis users or people looking to buy their first Mazak 5-axis machine, obviously they need to come and speak with you then.
Yeah, come and speak to us about the software. Obviously we've got a good partnership and relationship with Mazak now as well. We've programmed a couple other machines for the event here as well, so any 5-axis or any machining, any machine type, come and speak to us.